Does it see the software now?
Nope.
Why? Why is it doing this to me?
Because this software is janky.
It doesn't see this episode in YouTube.
Oh, stream is finished.
All right. Let's see what we can do.
So I'll have to start a new one.
Where is it? It says it's streaming out, though. I just don't know what it's streaming to.
It's streaming to episode 662. It's made a duplicate of episode 662.
Okay, I'm going to go in and I'm going to edit that episode to be the correct episode.
But you're not, but you're still frozen, right?
I'm switching cameras. Hold on. What? Okay. Can you switch the information on where we're going out to while I fix my camera?
I will try.
Okay, 1 second. I have to stand up. That's not a happy face.
Huh? For me?
Yeah.
No, I'm just focused, thinking.
Okay.
Okay. So I think it's working. So I updated the title and the graphic. Is there anything else that I need to do to make this not be busted? Okay. I think we're all right. And you're there?
Yeah, I'm just trying to get my green screen to green screen happier.
Okay.
Because when you switch cameras, all your settings change. Apparently my hair is just going to green screen.
It's the green in your hair.
It actually is. My hair
Yeah.
faded.
Yeah. You have a little bit of green in your hair. What were you thinking?
I was thinking that the dye was blue.
That's too green adjacent.
Yeah.
Even purples, I suspect, are dangerous. You're going to have to
Purples
stay.
are fine.
There isn't like a green component of the purple?
No. The blue dye and black dye are both dangerous. Black dye is almost entirely green dye, I have learned.
Yes. Yeah, of course. Yeah. Yeah, it's funny. We had some stuff that got painted in the house and we were going to go gray. Our walls are gray. And the painter was like, "Do you want green gray or purple gray?" And so there isn't just gray without some kind of undertone color in it. And so you get the gray, and you're like, "Huh, yeah, that kind of does look like we got the green gray." And so my walls look like people could see just like a tiny little bit above me here, and it's green gray.
Okay.
Katrina Astro YYZ. Finally able to watch a show live today, and I feel like I jinxed something. Yeah, possibly. No, this is before your time.
Yeah, we're trying to figure. I have no idea what the heck happened. But my camera was like, I shall not work. And I had rebooted and everything trying to fix it. And so I switched cameras, and the other camera is like, I shall not green screen. You cannot make me. And
It's fine.
it's fine.
It's fine.
Okay.
It just looks like the 1980s. That's all.
You know,
And my green screen works perfectly.
You don't have a green screen
That's
right now.
exactly it. Green screen. I had to go through, green. I would live in the green screen lifestyle while I was in the trailer, and no more.
Oh, man. Okay, opening up my audio software. My Mac is trying to be useful and not actually doing what I request, because that's sometimes what Macs do.
Using Audacity or GarageBand?
No, I'm using Audition, Adobe Audition.
Mm.
Yeah, Audacity, there was a version of OS X that was like, no, we will not run there.
Mm-hmm. Yeah, I think they sold Audacity to some other company. They've put in varying levels of spyware into it.
Yeah.
So.
No bueno. What are you using now?
Audacity.
Yeah. Dude.
Yeah.
Dude.
Yeah. It's fine. It works.
I love how we've all reached a certain level of, we just don't care who owns our data anymore for some things.
Mm-hmm. Yeah. Yeah. Is it an invasive spyware? Fine. But does it work well? Okay, great. I'll use it. No fuss, no muss.
Okay. I need to open up the names. So I had to reboot right before we went live. And then everything broke. And so I apologize, humans. Unlike last week where I had everything open but didn't have anything in my brain, this week I have everything in my brain and nothing open. And next week, the goal next week is to do both things.
Mm. A woman can dream.
It's true. It's true. All right, so I have that open. I am going to close Slack. I'm going to try and close Slack because you're already here. There we go. All right. I'm pressing record button 1. I am pressing
I have also pressed record
button 2. It is recording. Hi.
Okay. Here we go. Astronomy Cast, episode 667, JWST First Science Results. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. I had a super exciting thing happen on Saturday.
What happened?
The very first episode of Escape Velocity Space News aired on Now Media Television. Our new TV show has gone out to the masses, and we're going to be releasing the podcast and YouTube versions this week. So I'm hoping everyone will go check it out.
Oh, that's exciting. If you want to watch it on the television, where do you have to live?
So I can't keep track of all of the cities they have coverage in. I know that they're in Houston, I want to say San Antonio, Atlanta, Mexico City, and there are other cities. But if you go to nowmedia.tv, you can find out all the cities. And they also go out on Roku and, of course, on their own website.
That's cool. So if you have a Roku, you can subscribe to the Now television channel, and then you can watch. Or you can just watch it on YouTube.
Yeah.
Right. Yeah, it's funny, but like, what is a television show in this modern age?
Well, it's so weird because it's Patreon funded. when did TV start to be Patreon funded? But this is where we live, people.
Yeah, exactly. Astronomers came together in January to present their newest research. And not surprisingly, the Winter AAS meeting was heavy on news from the James Webb Space Telescope. What were some of the new results that were announced? And we're going to get into it, but first it's time for a break.
And I'm drinking soda. One moment.
Okay.
Sorry. Okay.
And we're back. All right. Now, you didn't attend this AAS, did you? You normally do.
Remotely. It's COVID is still bad enough that like going to 100-person event last weekend was like the limits, and I still was exposed to COVID, but like same room, different time blocks.
Right.
Yeah.
But you didn't get it.
No.
Good. Yeah, it's funny. So like the last time we were together was at the winter meeting of the AAS in Honolulu in 2020. And this was about a month and a half, 2 months into the beginnings of the pandemic. And I think we even had this very conversation. We're like, this is probably the last time that we're going to be traveling for a while. And true enough, I haven't been on an airplane since. So 2020, so 3 years now, I haven't been on an airplane.
Yeah.
But I'm ready. I'm almost ready to get back on an airplane and start to travel again. But I've been busy, with the forest. So, so what? I guess what were the big? I guess we're just going to dive into this. Let's talk about it. So, like, as I mentioned in my introduction, right? It was JWST news. Why was it so heavy on news from Webb?
Well, it was that sweet spot where folks started getting their data about 6 months ago. And 6 months is kind of the minimum amount of time needed for a well-funded research team, especially if there's a summer in there, to go from data in hand to analyzed result that's ready to be presented and in some cases published.
And so a lot of the time from up to this point, like the news that we've been seeing has been like someone from NASA has gone, here's a cool picture, and posting it on the NASA website with the bare minimum description, or some researchers, or there's been stuff that's been publicly available that people are poring over because some of the stuff is in open access. But a lot of it is proprietary research.
Yep.
They've booked time on the telescope. They got their data. Only they got it. Mm-hmm. And now they've had up to 6 months to analyze it, process it, and they were able to start explaining it to their cohorts at the American Astronomical Society meeting.
Yes. And the results that came out spanned everything from star formation in a whole variety of star forming regions to remarkable observations of some of the earliest detected galaxies in the universe. And it's hard to even figure out where to start because really the science spans the entire gamut of the profession, basically. There were even a couple of planets.
Right. So, I mean, were there any like large themes?
I think there were two big themes. One was star formation observed with JWST, and the other one was these early galaxies and don't they break our understanding of how our universe formed and evolved.
Right. Well, let's go into star formation then.
Yes. So back in July, we got that amazing, they named it Cosmic Cliffs image of the Carina Nebula. And the set of filters that they turned into that beautiful color image included filters that light couldn't pass through. So you have this yellow wall with the blue nebulosity above it. Now, when they instead only look at some of the filters, they're able to see through that yellow wall to all the star formation that's going on within. The Carina Nebula is known to be a remarkable star-forming region. There have been papers from Hubble coming out detailing solar system proplyds. These are the cocoony formations where a star is just starting to light up in the core. There have been objects called Herbig-Haro objects that are protostars that, as material flows in to them, some of it gets ejected then through jets in the axes of rotation. There's been a whole variety of these different young active stars detected in the past, but the detections have always been, we kind of sort of think we're seeing this, but we're not really sure. Well, when JWST hit the scene, it not only was able to go, yes, all of those are real. Herbig-Haro, young star, identifying all of them. It was able to also identify additional new objects, additional new jets. And the jets in particular are what we're interested in, because as a molecular cloud like the one that led to all this star formation in Carina, as it fragments and collapses into individual stars, the biggest fragments collapse down fastest. Gravity does that. Biggest stars form first. You get these jets coming out. Those jets then smush the other fragments around them, thus triggering more and more star formation, hollowing out nebula over time. This is a stellar feedback mechanism. And, well, once you turn off that yellow wall by going to longer wavelengths, you can see this stellar formation and this stellar feedback in action. And Carina was just one example of this. Hubble famously observed the pillars of creation, and that image has been used in just about everything since then.
Yeah.
Well, JWST got their own version of that image that we saw last fall, and yet again, we're seeing more of this star formation, identifying the details. And this is starting to allow us to get at something I think we're going to start hearing more and more about again. And this is what's called the initial mass function, which is the distribution of sizes that stars form in out of different collapsing and fragmenting molecular clouds. And by looking at all these different systems that have different contents, different masses, and seeing how stars of different masses form in different numbers, it starts to allow us to get down to the population statistics of these regions in ways we couldn't when we couldn't look through the gas. So yay for X-ray vision that's actually infrared vision.
And I think that release was like the perfect example of this first initial show off of a really great picture, but with not a lot of science going on.
There was
were
no
like,
science.
Here, well, there was some. I mean, but here is the Carina Nebula. Look at these cool cosmic cliffs, and they described some of the features, right? Like, you know that you've got this. Like, when you think about that picture, you're seeing the combined stellar wind of all of the stars that have already mostly formed and blown out their neighborhood, and it's like this combined wind that they're creating that is continuing to pile up and blow away this material off into space, and eventually the whole area will be clear to feel a lot more like, say, the Pleiades. But for now, you've got the parts that are in nebula and out of nebula, and then you got to see a few little knots and regions and stuff. But this time around, now they've gone back through and they've measured things, and they're saying, like, here's a star and there's a star and here's a jet, and then they're measuring the amounts and quantities, and they're also looking at the kinds of chemicals that are piling up. And so you get this detailed analysis of 6 months of the astronomers doing their job on what was a beautiful picture, and in many cases is probably some of your phone wallpaper right now. But we got the analysis of that picture, and that for astronomers is really interesting, because no star forming region has been imaged at this level. And I think, like with Hubble, we have images of the Carina Nebula taken by Hubble, and we have images from the Eagle Nebula, but but Hubble has some infrared capability. And so Webb was able to give far more resolution and also peer through a lot of the gas and dust that's obscured to Hubble to see even more features. And so they're looking at many new objects that had never been seen before, as well as being able to confirm the objects that Hubble had already seen. So yeah, just amazing research. And that is, I think, just like the perfect example of a gorgeous picture.
Yes.
And now the follow-on science, which is just as interesting to astronomers and hopefully to the public.
And with both of these systems, it's really a matter of looking at the forest, where we're seeing the entire region of star formation going on. But there were also opportunities where it was able to focus in on not just individual trees, but their leaves, you might say, to carry that analogy far too far. And this is where they have this tremendous image of Wolf-Rayet 140, which is a binary system with a Wolf-Rayet star. It's about 10 solar masses, and a companion that is an O-type star, about 30 solar masses. And these two systems go around each other every 7.9 years. And when they do, it compresses out a shell of material. And so we're able to see these individual shells that are getting compressed together through orbital mechanics and gravity playing together as this young star is settling down into its very short life. It's these kinds of details that JWST is going to allow us to hopefully start to understand some of the more complex interactions that just haven't made sense to us as we'd like. We're seeing the same thing happening with planetary nebula and other forming stars, and there's just, where do you want to go next?
Yeah. All right. Well, we'll figure that out in a second, but it's time for another break. And we're back. All right. So the next big theme was on the cosmology side, the large-scale structures in the universe, the things that are most distant.
And this is where, again, gravity is just going to keep playing an important role in our JWST discoveries. Even with all of its light collecting area, even with all of the magnification it's able to do, it can't, in a reasonable amount of time for the number of astronomers who want to use it, directly image the first galaxies in the universe without getting a little bit of help. So what we still are waiting for is for JWST to do like Hubble did and just look at a mostly empty section of space and stare and stare and stare and stare and stare and let us see the faintest objects directly. Instead,
They've done that.
They have a deep field that includes an Abell object.
No, they've got a deep field of one of the Hubble original deep field. So they did the same region in Ursa Major, and they went for I forget the number, but it's long. No, they've done their version of a sort of like a first take on a deep field, but they're going to be doing this every year. And it saw 10 times as many galaxies as Hubble, 100,000 galaxies, was able to see objects out to.
So they have things that they're calling deep fields, but they're both centered on galaxy clusters. Because there's the SMAC system, and then there's... Okay, so I see
the SMAC one. Yeah.
So that's a galaxy cluster.
Hold on a second. We're going to have a fight about this. Let me get the... They did 9 days of observing, and it is the... see what the location is. I can give you the link if you want. They actually did this. We reported on this back in December.
Right. So they have a field that they're calling their deep field, but it's centered on a galaxy cluster.
No, it's the Jades. It's the Jades. The Jade survey. So the JWST, the extragalactic survey, and it's done in the same region as it's in Ursa Major, which is the same region that the original the original Hubble Deep Field. Later, they did the Fornax one for their ultra deep field, but originally they were in Ursa Major. And
Okay.
so
Where
they
did you drop me the link?
put it in the Wirecast chat over on the right.
Okay.
So, like I said, they did 9 straight days of Webb observing time. And what's exciting about that is that they were able to do it without having to look around. Like they don't have to go around the Earth. They just stared nonstop.
Oh, they don't have science from it yet. That's what's going on.
Yeah,
Okay.
but I think the data, I think the images and information was released publicly, so it wasn't part. Like I said, it wasn't. You said they haven't done a deep, but they have. That's all.
Okay. Okay. So I will amend what I was saying. They still don't have science out on that, which is why I missed it. I was trolling the published.
But I think like the big question that people are asking is these first galaxies. I mean, this was one of Webb's main priorities, to see these first galaxies in the universe.
Yeah, and I was going to get at how you saw them first with gravitational lensing. So, ask the question again, and we'll try this again.
All right. So the next big priority for Webb was, I guess its other main job is to see galaxies out forming at the very beginnings of the universe.
And at the JWST meeting, the research that we had to look at, the published results, are based on two different fields that contain galaxy clusters that we're using to basically fast track us to being able to see the earliest objects in the universe in as little telescope time as possible. These two fields included an Abell cluster, a SMACS cluster, and these two systems, their mass allowed us to see magnified and enhanced amounts of light from galaxies we now have confirmation are 350 and 450 million years after the Big Bang is when we're seeing them. Yeah. And they were already formed, and they're extremely bright. There's two different competing research teams that published on these. One was led by Rohan Naidu from MIT, and the other one was led by Marco Castellano of the Astronomical Observatory of Rome. And so when you have two different teams both confirming the same look back time for these two systems, that tells us that yes, JWST is seeing things that long ago. And we also see evidence, still needs to be confirmed, still needs to go through peer review, potentially of bright galaxies that we're seeing them as they appeared just 200 million years after the Big Bang. Yeah.
And that's within the capacity, probably through gravitational lensing, though. It's going to take...
Exactly.
Yeah. And I think one of the things that's quite surprising is how well formed these galaxies are. I know with one piece of research, they saw fairly mature looking spiral galaxies just like maybe 1 billion years after the Big Bang. And galaxies that would look identical to what we have today.
And this is one of the things that the high resolution that JWST is capable of acquiring data at is allowing us to see that there were already not just brighter than we expected galaxies, but bigger than we expected galaxies and more maturely formed galaxies. And this is causing a rash of two different kinds of papers. One is saying cosmology is wrong. We don't understand it. JWST overthrows cosmology.
I don't think that cosmologists are making that claim. I think you have some people who are alternative theorists who have been pushing that diatribe for decades now and are looking for any little crack in observations to push that narrative.
So the
No.
narrative is related to the structures of lambda cold dark matter, where the question is, can we understand the ability of dark matter, which we don't fully understand, that is moving fairly slowly, that's the cold part, to quickly form massive structures. So on one hand, we have the folks that have been doing some fairly sophisticated computer modeling saying, yeah, you can't get things that big that fast. Now, on the other hand, you have the star formation people going, wait, early universe, we don't understand the first stars. So the argument is actually coming down to, were the first stars so much brighter, and was their initial mass function, to bring that phrase back again, was their initial mass function so different from what we're used to seeing in the modern universe that it was possible to have exceedingly bright, 10 times brighter than expected, galaxies within those first few 100 million years? Or is there something in our understanding of how the early universe, like molecular clouds, fragmented and collapsed? Which of those two things, or both, is where the struggle is? My personal feeling is that we don't have a good understanding of the initial mass function of the early universe because you only had hydrogen and helium. And we know that the initial mass function is strongly related to the metallicity of stars. So I'm leaning that the majority of the problem is going to be on stars were just brighter back then, and we're still understanding that.
All right, we're going to talk about this some more, but it's time for another break. And we're back. One of the observations that I really enjoyed from this round of press releases was the imaging of objects that look like green pea galaxies. And these were a finding by a team of citizens. Was it Galaxy Zoo? Anyway.
It was galaxies.
Yeah, found these weird galaxies that are green pea galaxies. And so they're mashed together, and you're seeing the light coming, the collective light from all of the ionized gas in the galaxy. There's so much ionized gas in the galaxy that it's just glowing in the ultraviolet, and it appeared green in the images. Not that it's actually green. And JWST was able to find examples of these galaxies early on in the universe. And although the wavelengths were pushed into the infrared,
right,
by all means, they matched these green pea galaxies. And so what's exciting about that is you get this connection. You got these things that are very close at hand and are relatively easy to study. And you got a confirmation that these things are very similar to the things that we saw at the beginning of the universe. And so you can study the ones that are nearby, that are easy to get your hands on, and know that you're looking at something that is kind of primordial. It's like people pulling up a coelacanth from the bottom of the ocean, this primordial fish, and knowing that this thing's been around for this long. You can study an alligator or a crocodile and know that a version of this has been around for hundreds of millions of years. So I really enjoyed that story and sort of what the implications were.
I'm really enjoying the fact that as we're able to see better and better in the infrared, we're able to see that the expansion of the universe has just taken things that are familiar in the ultraviolet in the modern universe and shifted them. So in the Middle Ages, they were optical colored. Hubble showed them to us. And now we're seeing the exact same objects from early in the universe that are shifted all the way into the infrared. And this confirms to us that while so many things have completely changed, the metallicity content of the universe, the number of heavy atoms, essentially, the basic physics of how things turn on, how they form, what they look like, is the same at every single epoch, except for maybe that very first epoch, because there was only hydrogen and helium.
Now, did we get any planetary news?
There was. So Hubble was able to confirm
Hubble or
tests up
JWST?
JWST.
Okay.
I'm going to say the wrong thing periodically. Forgive me, humans. JWST was able to confirm a test source. It had been seen as two rough transits. Previously, it was seen again by JWST, and with JWST's abilities, they were like, yes, this is a planet. And there was another world that originally they thought maybe this isn't a planet because there was a double eclipse, and the thinking initially was that it was a sun-like star and a Jupiter-like planet, and with that size of a planet you shouldn't be seeing both kinds of dips. But then they redid some of the star's physics, and they were able to figure out, no, wait, this is an object that the star is actually significantly bigger, significantly hotter, and yes, that is also a planet. So we're at the finding planets. They are starting to look at atmospheres. They are still in the stages of eliminating stuff that they don't see. But getting down to the stuff we're interested in, like carbon dioxide, is going to take a bit longer just because it's harder to observe. It's deeper down in the atmospheres.
And there was another image, and this isn't exactly planets. I guess it kind of is, but it was a picture taken by JWST of this fairly famous newly forming planetary system called AU Microscopium. And the star system is fairly new, and it's relatively close, and it's seen edge on. But what was cool was you got a chance to see the coronagraph from JWST in operation. And so it was blocking out the light from the star, and you could see the protoplanetary disk surrounding it. And astronomers have already found multiple planets in this disk. And so you're seeing the leftover planetesimals that are all crashing into each other and creating this rubble area around the star that is probably still causing mayhem. So when we think back to the early age of the solar system with the late heavy bombardment period, you've got that rough period that these planets are going right now in this nearby star system. And it's an amazing picture to see this. The star is gone, and then the fainter objects around it are revealed. So very cool.
And there's my favorite star, and I have to look at its license plate every time. It's a star in Taurus, L1527. And this is one that you interviewed the scientist who worked on it over on the Weekly Space Hangout. And it's a fan-like structure coming out from this little tiny dark line of a disk in the center that has a young star in the very center. And the light coming out in cones, just like a flashlight beam into a dust storm, allows you to see all the structure of the gas around this young solar system. And I just love the ability that we're finding with JWST to make out the fine structure. A bunch of new work on the Southern Ring Nebula is showing very similar. Okay, let's turn on just this one narrowband filter. Okay, so we see the hot gas in the center. Let's turn on this other filter. Okay, now we see all this filigreed ring structure, including planetary nebula form through the basically exhalation of the atmosphere of a star into the surrounding space. And in the outskirts of this, you start to see faint individual rings from when the material was getting blasted off of this young white dwarf.
Very cool. All right, we're going to have to wait another 6 months for the next big AAS meeting, and then I'm sure we will see another, probably even more comprehensive list of stories coming out of JWST. Thanks, Pamela.
Thank you so much. And thank you to all of our audience members whose names I replaced with information on AU microscopy. One moment. I'm sorry, humans. I was like, wait. I don't think
you
I
have to
read
see
that
the
one.
picture. Yeah.
Yeah. Thank you, Fraser. Thank you, Fraser. And thank you so much to all the people out in our audience who support us through patreon.com/astronomycast. This week, I would like to thank by name Michelle Cullen, Dean McDaniel, Scott Briggs, J. Alex Anderson, Michael Regan, Benjamin Carrier, Matt Rucker, Peter, Abraham Cottrell, Shersum, Jim McGeehan, Frodo. He gave me pronunciations that include a character I don't know what it means.
It's not helpful.
Okay. Frodo, I'm going to figure this out. Frodo Tenenbaum, Philip Grand, Mark Stephen Rasnack, Antasor, Brent Karanop, Father Prax, Dwight Ilk, Bruce Amazine, GeForce 184, Dustin Ralph, Planetar, Alex Rain, Glenn McDavid, Andrew Stevenson, Paul Hayden, James Roger, Sean Matz, Mansky, The Mysterious Mark, Karthik Vekatraman, Sam Brooks, and his mom. Thank you all so much. And thank you to all of you who are putting in pronunciation guides. And dear human whose name I continue to mispronounce, I'll look up that letter that was deeply mysterious. Thank you.
All right, we'll see you next week.
Bye-bye. And then they saved. I'm fascinated how, because I am crawling journals and mainstream press, not mainstream, Eureka Alert press releases, and you're clearly crawling other places than I am. We end up with different stories sometimes.
Yeah. I try to catch everything.
I recognize that and I appreciate that. And I had Googled.
So if you see
Hubble.
something that I haven't seen, then it's really just a failure on my part.
But like I had Googled JWST deep field, and if you Google that phrase, it won't get you there. No.
Really?
Yeah.
Hold on. But maybe it's ruined for me.
I bet that Google's giving you and I different results because we use our browsers differently.
Yeah, so if you do it, then I get the 1, 2, 3, 4, 5, 6, 7th story down is Webb completes his first deep field. So you probably get a different personal. If I type JWST deep field, we're number 7. You don't see that?
So hold on. I'm going to repeat the experiment.
Okay.
JWST deep field. I have you further down the page.
Mm-hmm. Yeah, okay.
So yeah, you're down at the bottom and I hadn't scrolled that far.
The December 12th one. Yeah.
Yeah.
Yeah. It is legit. It is everything that people wanted. It is retaking the same region that Hubble did its deep field in. It found 10 times the galaxies, including 4 galaxies that were formed in cosmic dawn. Like it's exactly what you want. And it is like, it's like, I think just because NASA didn't produce a press release. So we got it. Where did we get it? Whoa, the writer has failed me. Evan.
Yeah.
That's weird. So I wonder what the source was on that. So we've got 2 papers that came out. Discovery and properties of the earliest galaxies with confirmed distances and spectroscopy. But there was a press release that we got from this that we got the clue. Huh.
Okay, let me see if I can.
Yeah. Anyway, I wouldn't worry about it. The point is just that it's been done. Yes, it
But
exists.
I looked for it and I missed it.
So like I've mentioned this in the past, that the big modern problem is that people don't know how to recognize news. And so they need a press release to tell them that something is news. And whether or not the research that you do turns into a press release just depends on whether or not your press officer in your university has time this week. And if you wrote a good title for the description of your story. And so yeah, I think we were the only people that covered this, right? Everyone loves the Hubble Deep Field. We reported on this. I did a story about this on our Space Bite. Like, we did a ton of coverage on this because I knew how important the story was going to be. But if you don't get the echo chamber that goes on, people don't know that it's happening. And so we're not big enough where we can break stories and other people report on what we're reporting on, although it happens sometimes. Like, you'll see Futurism will say, like, Universe Today is reporting on blah, 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 but other people don't. And so we're covering the NIAC Awards right now. We're probably halfway through them. And I don't see anybody else talking about more than just a couple of them. But we're covering all of them on the website. I'm interviewing every single one of the teams. I'm partway through the interviews right now. I'm going to try anyway. Like, it's a funny thing. Like, I don't know what the answer is. I mean, we just got to keep on doing what we do, I guess. But like, I think because people aren't seeing the same information from many different sources, it's on CNN, it's on BBC, and all these places. People don't even know that we're reporting on stuff that's interesting and important.
Yeah, and I'm clearly guilty of just not scrolling far enough down. And this is something that happened the week of my birthday when I was away. So I missed your coverage. It didn't come up in a Google result within the area that was on my screen without scrolling.
Yeah.
And
it's really like, in another like, there's other cases where we'll report on something like 3 months earlier than other people will, because I see the paper and I'm like, oh my God, this is a huge story. And so, we report on the original paper, and then, or maybe we report on the prepress, and then it gets accepted for publication. It's largely unchanged. It's published in the Astrophysics Journal or whatever, and then it comes out, and then that's when the press officer. And so there's been a couple of times where there's been a story that we've been on, and then we report on it. It doesn't make a lot of excitement out there, and then the story comes around again, and this time it gets the press release, and now everybody's reporting on it, and it's the same news, and then, like, what do? Like, we're not going to talk about it again. We covered this 3 months ago.
yeah.
So these are
So
the kinds of challenges that we face.
The way that gets handled in newspapers is they'll put an editor's note at the top saying the paper discussed in this story was published on, and then give the publication date, and then rerun it on their front page.
Right. Yeah. I'm not going to do that.
I'm just telling you how they do it in mainstream news.
Mainstream. Anyway, let's take on some questions.
Okay, I'm going to open up Twitch, see what's going on over there.
Hal McKinney asks, are the magnetic field lines of large celestial objects affected by gravity? Gravity?
They're different forces.
But wait a second, though. So, like, gravity affects light. Like, light passing by gravity is affected.
Yes.
So wouldn't, and photons are essentially magnetism in another form. So would magnetic field lines be impacted by gravitational wells?
So it's not going to be a dominant force. And I'm not sure it's something we could detect. So, for instance, if you have a magnetar that we're able to measure its magnetic field through Zeeman line splitting, those individual electrons that allow us to detect that magnetic field are telling us about their magnetic field right where they are. What we can't get at is the details of how magnetic fields are going to get gravitationally bent further out. Even like, I'm thinking of there was a recent paper that had Juno's data on how Ganymede's magnetic field lines reconnect with Jupiter's magnetic field lines. And yes, gravity's playing a role there, but the magnetic field is the dominant thing, and those second order effects are just not something that we're measuring right now.
Right.
So yeah, it's affected, but we can't get there from here. Does that make
Yep.
sense?
Yep. Series Kaylee, what gas is ionized giving the green pea galaxies that color?
I think it's oxygen.
Yeah, I think it's oxygen, and it's just you're seeing ultraviolet. Like they're glowing hot in the ultraviolet.
Yeah.
So the green was a result of the survey that they were doing, that the galaxies looked green in their images, but it wasn't. They were like, when you're imaging, when you use multiple filters like hydrogen, oxygen, and sulfur, usually to do different colors.
Yeah.
You'll apply the red to hydrogen, the green to oxygen, and the blue to sulfur. And so green was oxygen, and so they look green because they're high in oxygen content.
Yeah. Here's one that you may have had better luck than me. Raj Luthra is asking, has anyone managed to see C2022 E3 ZTF?
Yeah, I've been cloudy.
Yeah, same.
And it's still not great right now. It's still fairly low on the horizon, but so I would still wait another week and a bit. Early February is when you're going to want to look. Like, wait till February 3rd and then look, take your binoculars and scan in between Ursa Major, Perseus, and Cassiopeia. It's going to be in this line between those constellations, which is exciting because they're easy to find. Like, everybody knows where the Big Dipper is. Everybody knows where Cassiopeia is. And so you can just run your binoculars in that area and you should see the comet. And I think some people are saying that it's just barely naked eye visible at this point.
Yeah, there were some folks in Spain who were able to spot it with the unaided eye. The frustration I know I had was, like, it was new moon and clouds, more clouds. And so while there were folks in Spain able to see an unaided eye, as the moon gets brighter and brighter, there's going to be this, okay, so the comet is a little bit easier, but now the moon is a little bit more interfering. So there's trade-offs.
We've got a couple of minutes left. I know we had a late start. So I have one quick announcement, which is that the 3-body problem is now available as a TV show.
Have you watched?
I'm 4 episodes in. There's 10 out already. And the great thing about Chinese television, Korean television as well, is they just dump the episodes out every 2 days or so. Like you can binge the whole thing. And it is a very accurate retelling of the 3-body book.
Okay.
So it just goes into great detail about this poor scientist who is seeing numbers counting down in his head. And you can see it on Viki, Viki, and they've got English subs on it.
Okay.
And so it's like, it seems like they're faithfully, like, if we watched the cartoon as well, and it has very little, like, they start with the most interesting action-packed sequences out of the book. But with this one, they are trying
cartoon.
Yeah, there's a cartoon. So it's on Bilibili or Tencent. Anyway, yeah, and it's, like the scenes are over the top, very action packed in the cartoon, and loosely affiliated with the book, but with the TV show so far, it's a very close connection to the book itself. Um, and so it's all great when it's a scientist who's seeing numbers in photographs, and people are working at giant radio telescopes and sending messages into the cosmos. As you know, like maybe
Right.
there's a few crazy things that happen partway through the book on the first one, but like the second one, I can't even imagine where they're going to find the budget to do season two. If it, like I don't even know, like it feels like they're doing like, and they do like so many episodes. It's like 30 episodes are planned, I think, for just
That's
season one.
amazing.
And I don't know whether it's going to be the whole show or whether it's whatever. And I think Sears K. Lee is saying, I hope Netflix doesn't whitewash it too much or dumb it down. So this is the Chinese take on a Chinese book,
Yeah.
like a well-respected but Chinese science fiction book, and it's problematic. Like if you
Yeah.
read The Three Body Problem, there are some very problematic
Yeah.
concepts in this book. A lot of like Uyghur denialism. Like there's some stuff in there that you will turn your stomach, and
Yeah.
not like ooh, that's so gross, but more like,
No.
that is
Like, oh,
morally outrageous.
humans.
Oh, yeah,
Yeah.
exactly. And then you see and then like in the second one, like they make a lot of emphasis that men have become more weak and feminized,
Yeah.
right?
Yeah.
And you're like, oh, come on, right? And so we'll
Yeah.
see if they go down that route as well. So I'm sure so Netflix is going to do their version of it, and I'm sure it's going to be it's the people who did Game of Thrones, Benioff and Weiss. But it is funny to see like they have to have other nations in this show.
Right.
So they've got like a German doctor, and they've got a couple of representatives from other countries, but everything else is China, China, China. And I think for people who wonder what it feels like to be a minority in a country like the US or Canada and not see yourself represented, like that's what it feels like when nobody who isn't Chinese has a speaking part, right?
Right.
So they don't even say the nations. Like in the translation, they're like, you come from nation T. You're like, who? What is nation T? So, you come from nation N. I'm like, what is that? So, anyway, it's so far it's entertaining though. Like I am entertained. I am enjoying it.
Are you
So
able to pick up the Chinese at all?
I could get a rudimentary version of it, but it's very technical.
Okay.
So, and so I can catch, like I seem like when I'm watching the translation, I'm like, oh yeah, I totally heard him say that's no problem, but no, I'm watching it just with English subtitles. Yeah. So anyway,
Slaves.
that exists. That's a
Yep.
thing that exists. So if you enjoyed the books, but again, like if you want to have that same part, like entertained, if you enjoyed the Three Body Problem, you enjoyed the range of ideas and the scope and the horror and dread of ancient civilizations that are beyond power that we can even comprehend, I highly recommend you read the Revelation Space series by
Now,
Alistair Reynolds. So
yes. So here's a question right in line with that. So Z Zinc is asking, what is your one must-read science fiction book?
this, yeah, Revelation Space now is my current nerd out, because like he's a PhD astrophysicist who is a terrific writer. And so he's speculating aliens are attempting to dismantle, or alien robots are dismantling a star, and they're trying to figure out why. And so they're explaining how you would dismantle a star and why you would do it. And they're all deeply legit, right? It's not just hand wavy, let's take a star apart. It's more like, here's the methods. And there was an idea that I hadn't even thought of, that you build a magnetic field around the star.
That
And
would
then
do
as
it.
the star is turning, you are interacting with the magnetic field of the sun, and then you start to
Yeah.
spin it up like a motor.
Yep.
And then over time, the star is spinning so fast that it just tears itself apart. And you've destroyed a star. Like, if
That
you want
would
to
be
destroy a
a very
star,
fast rotating star.
yeah, just keep it rotating faster and faster and faster. You just speed it up and speed it up and speed it
Yeah.
up. You just take its energy
Mm-hmm.
and feed it back into an electric field that spins up the star. So
Yeah, no, I totally see how you would do it. It's just one
yeah,
of these, I don't want to calculate that type reactions.
no, but he can, right? So he does the math, which is
Yeah.
great. So it's like all the things that the three body problem is weak on, like characters and the reality of the science. Revelation Space. So Revelation Space is very much Mass Effect meets the three body problem.
Okay.
So if you like both of those things, especially Mass Effect, again, it's like Mass Effect was clearly inspired by this series. So, yeah, it's great.
Excellent.
I love it. I just love it. I love every part of it. So
Okay.
so far,
I now know what my next read is.
the hero of the second book is one of the Borg, essentially, and he remains one of the Borg
All
the
right.
entire time. Yeah, and he's the hero
Okay.
of the So, all right, we should wrap this up. So thank you everyone
Yep.
for joining us today. Thanks for everyone watching us on YouTube and on Twitch. Thanks to our moderators. Thanks to Pamela for bringing the brain. Thanks to all of the editors and producers working behind the scenes to make this show happen. We will see all of you next week. Thanks, everyone.
Bye-bye.